So in this video, we will talk about similar figures and scale factors. So basically, whenever I am presented with a scale factor, I want to multiply. So scale factor is a number multiplied by each side length of a figure to create a similar figure. And this can be written, that scale factor can be written as a fraction, decimal, or a percent. So we always talked about utilizing certain symbols to help us understand what is corresponding. So the symbols we talked about was the squiggly line, the straight line, and then the dashes. Okay, so I'm going to show what corresponds to the next one. Okay, so this 7 right here corresponds to this 21. This 7 corresponds with this 21. And this 5 right here corresponds with 15. Okay, so obviously we can see when creating this figure right here, we can see that each side is multiplied by 3. Because if we do 3 times 7, 21. 3 times 7, 21. 5 times 3, 15. Which means that the scale factor from figure 2 is 3. So that's our scale factor. They multiply times 3. Okay? Now, we notice that a scale factor of 3 makes this second shape get bigger or enlarges it. Bigger or enlarges it. Okay? Now, to calculate the scale factor, let's say if we don't have the scale factor, we divide the side length of the new figure by the side length of the old figure. So remember, this is when we don't have the scale factor, we divide. And you're going to hear this quite often. You're going to hear your teacher say, hey, new divided by old. You may hear your teacher say, hey, they may say prime divided by original. So right here, I've already placed my notation here. I'm going to let this one represent my old figure, and this is my new figure. Okay? So remember, it's new divided by old. That's whenever we are trying to find the scale factor. So I'm just going to take that side length, which is 6 divided by 12. I pull the 12 from the old one, and I get 1/2. So that is my scale factor right there. Now, one key thing I want you to see with this is that when you use labels, it really helps you define things a lot easier. It helps you eliminate you possibly using the wrong thing. Now, one thing we noticed that a scale factor of 1/2, if you observe this, it went from this to become this. We noticed that a scale factor of 1/2 makes the shape smaller or reduces it. Now, on the last one, we noticed that the scale factor was more than 1. And it became bigger. So anytime it's more than 1, your shape is getting bigger. If it's less than 1, it is getting smaller. So that goes down to the properties of scale factors, which is very important. Scale factors greater than 1 makes the shape bigger or enlarges it. Scale factors less than 1 makes the shape smaller or reduces it. And scale factors equal to 1 basically keeps the shape the same size. All right. Now, we're going to take a look at this next one right here, which is we got two triangular prisms, It says figure 2 can be found by dilating the dimensions of figure 1. Whenever it says something about it's being dilated, the part that's being dilated is going to be your new portion. Okay, so it says that the new figure, which is figure 2, can be found by dilating the measurement of figure 1 by a scale factor of 0.75. Remember what we talked about? We said, hey, if they already give us a scale factor, we should just simply multiply. Okay? Now, let me just put some symbolizations on there so I can know what represents what. This is going to represent this one because these are corresponding. This represents this because that is corresponding. And this represents this because this is corresponding. Now, all I have to do is take my original and multiply times the scale factor, and I get 9. I take the 4, which is going to represent my new y, multiply times the scale factor, and I get 3. And all I have to do is take z, and let me put a little mark through that so you can know that's not a 2. I'm going to do 24 times 0.75, and I get 18. So remember, if you already given the scale factor, just multiply. That's it. Just multiply. Now, think first. We know the scale factor of 0.75 means my figure 2 should get what? Smaller because it's less than 1. And then I can see that x should be less than 12. Y should be less than 4. And z should be less than 18. And 24. And we obviously see that these numbers right here are all less than these original numbers. And that's the basics of scale factors and dilation. Like I said, the key component is the properties of scale factor. If you can remember that part, you will be absolutely fine with scale factors and dilation.